This experiment, we're going to be looking at the characteristics of the solar cell based on the temperature it runs at. They don't always behave the same at all temperatures. So how does the temperature affect our solar cell? Very simple setup. You see we've got our digital voltmeter here hooked up to our solar cell. The solar cell is attached to a thermal mass, in this case just a piece of structural aluminum. That'll kind of slow down the temperature change. I have a medical thermometer here. This is one that I picked up from a local drugstore, just an inexpensive one. And I've got it set for object temperature, not body temperature, so it actually measures the temperature of objects. And I have a hairdryer, and the hairdryer is going to be used for warming up my material. You can use whatever you need to warm it up. I'm going to use this hairdryer. So we'll start by warming up the body. And now this is where you have to start acting quickly. So we have it's very nicely warmed up. So we'll make the measurement of the solar cell. It's 106.3 degrees. And on a spreadsheet, I'll notice 106.3 degrees, it's 4.51 volts. Then you measure again. 100.1 degrees, it's 4.55 volts. You measure again. 95.6 degrees, you measure 4.58 volts. And you keep doing this, measuring the temperature and the voltage as the object cools down, and logging it all on a spreadsheet. And then you can do a plot of the voltage versus the temperature of the solar cell and get a really good idea of just how it's responding. And you may notice my solar cell is actually increasing in voltage as it cools down. But let's see how yours does. After you've done this, you may be interested in finding out how it behaves with current. So we're going to measure the short circuit current of the solar cell. And once more, we're going to warm up the body. And we, once more, take the measurement. 112.6 degrees, 2.04 milliamps. 106.2 degrees, still 2.04 milliamps. 101.9 degrees, 2.03 milliamps. 100.2 degrees, 2.03 milliamps. And you will continue as it cools down to measure the currents at these various temperatures to see how the current is affected by the temperature. In my specific solar cell, I'm not finding as much of a difference as the voltage, but there was a change. So all of this information can be logged to your spreadsheet, and then your spreadsheet can be charted to a graph to see what the temperature versus voltage and temperature versus current response is for your solar cell.